Hey guys, so welcome to day 2 of test review. I remember I didn't make a video for day 1 just because that video would have been like pretty much identical to Wednesday's video, so if you are wondering if there's a video for day 1, there's not, just for day 2. So today we are going to focus on getting ready for the test, and yesterday we talked all about solving equations, and so today we're going to focus on functions and then domain and range. So for the starting point here, we are going to evaluate and solve functions. So if I was given this function right over here and I was asked to find f of 4, remember finding f of anything is just plugging that number into your equation for x. Okay, and then I would just have to calculate this. So the square root of 4 we know is 2, and so 2 plus 2 equals 4. Right? It is a coincidence that f of 4 ended up equaling 4. It's not always going to be the case, but in this case it was. Okay, and then for the next part here, f of x equals 5, right? And we want to find x. So notice how the problem itself looks different. It's worded different. That should be an indicator to you that we are doing something different. So this is where we take our f of x and set it equal to 5, right? This 5 came from the equation. Alright, so now that we have set it up, we can go ahead and start to solve for x. So the first thing we're going to do is subtract 2 from both sides. And this is so that we can start getting x by itself. So on the left we have the square root of x equals 5 minus 2 is 3. Okay, and then this step right here is what a lot of people tend to forget. If we want to get x, right, we don't want the square root of x, we want actual x. To get rid of the square root, we do the opposite of square rooting, which is squaring. So if you ever find yourself in a circumstance where you're trying to get rid of a square root, you just have to square both sides. So we know that x is going to be equal to 3 squared, which is 9. Okay, and that's it for that. So just remember, f of a number is to plug it in, and then solve x when f of x equals is to set your equation equal. I think most people are starting to get the hang of that. Alright, next we have a question where we have to graph a parabola and find all of these key pieces. We've been doing this for a hot minute now, and I think people are getting better at it, so hopefully by the time we take the test we'll be good to go. So we have our calculator here, and what we want to do is to first graph them, right? We want to go to y equals, and I have typed it in here for us already, but this is where you're going to type it, and you will hit graph. And we'll have our nice little parabola there. And so we're going to want to find all of these information pieces, and then we want to make our graph. So let's start by finding the x-intercepts. So x-intercepts are where we touch the x-axis, so we have one right over here at 1, 2, 3, 4, negative 4, and then one here at 0. So I'm going to go ahead and write negative 4, 0, and 0, 0. Notice how I'm writing them in parentheses with a comma in between. That's exactly how you want to type these things into MyOpenMath. Alright, and so let's take a look at our y-intercept. If we look at our y-axis, okay, the y-intercept is actually also 0, 0. And, you know, fun fact, anytime your x-intercept is 0, 0, it will also be a y-intercept. Because, as we know, 0, 0, that point is on both axes at the same time, because that's where the axes intersect, right? Next will be our vertex. So that's this guy right over here. Now, we can look at the tick marks and see that it's, if we like follow it back up, it's at negative 2 on the x, and right down here it's at negative 4 on the y. So negative 2, negative 4. Alright, at this point let's go ahead and draw our graph. We have enough points to do it. So we can start with our vertex, negative 2, negative 4. And then we have a point here at 0, 0, one at -4, 0, and I'm really going to try my best to make a good graph here, but it's probably going to be ugly, guys, so okay, yeah, it could have been worse, right? Alright, so we have our parabola there, and now let's go ahead and answer the rest of these. So minimum is the lowest point, and here our lowest point, we actually have one, it's our vertex, so we're going to say -2, -4. Our maximum, this thing goes up forever and ever and never stops, so we don't have a maximum, we don't have a highest point. Domain and range. So domain, it goes on and on in the left direction, and it goes on and on in the right direction. So our domain is going to be -infinity to infinity. Okay, and again, that's because it just doesn't stop, and it's going on forever in both the left and right directions. Alright, and so the range, now for this one, our lowest point is right here, right at -4. And then it goes up forever. So our range will go from -4 all the way to infinity. Now remember to put parentheses on infinities and brackets on numbers, unless if there's an open circle, which we don't have that here, so. Alright, and then line of symmetry. That's this guy right here, the line that will cut your graph in half. So it's always going to be x equals, and then the x value here is -2. Alright, and that is it for that question. Going on to our next page here. Here's another domain and range question, but for a differently shaped graph. So, domain, remember, left and right, x values, that stuff. So for domain, our leftist point is right here. And because we're focusing on x value, we know our domain starts at -3, and it goes on forever and ever in the right direction, so it's going to go all the way to infinity. Okay, bracket on the -3. For range, green, we want to go lowest to highest. Remember, it's always smallest to biggest. Now this thing is kind of pointed in a downward direction, so it's going to go down forever, but it won't ever go higher than this point right here. So because it goes down forever, we'll start at -infinity, because remember, start with lowest, and the highest y value is 3. And don't forget your bracket. Okay. And so remember, range is all the y values, domain is all the x values. Alright, back to Juniora and her piggy bank. So let's say she has $200 in her piggy bank to start with, and she's saving up, so every month she adds $150. Now for my equation, remember that the general form is y equals mx plus b, right? That's the slope-intercept form. Your m is going to be your rate of change. So that means your 150 is going to be your m. Many people made this mistake on the quiz by swapping the numbers. So make sure you're aware that your change value is m and your starting value is b. So in our equation, we know it will be y equals 150x plus 200. Okay, making sure that the m and the b are in the right places. Okay, and then for our table, all we got to do is we can plug in each of these numbers, or you can just do the math yourself, right? So at 0, that's our starting point. We're at 200. And then each month we're adding 150. So now it'll be 350. Then it'll be 500. Right? Again, all we're doing is adding 150, adding 150, adding 150 each time, because that's what we know is our rate of change. So here we'll get 650, and then we'll get 800. All right. Now that we have our table, we can very easily make our graph. It's just going to be a line. So at 0, we'll just plot our point at 200. 1 is at 350. 2 is at 500. 3 is at 650. And we've got 4 at 800. So by the 4th month, she will have saved up $800. Alright, let's go ahead and draw a nice straight line here. This will be neater than anything I could draw with my pen. Okay, and then we are good to go on that. Make my points a little bigger. Okay. And that is all you have to do for this situation. And on to the next page. Alright, so this is another alternate way Juniora could save money. It's kind of similar to the last one, but a little bit different. And now because we haven't learned about this particular type of equation, we're not going to set up the equation, but we can model her situation anyway, just because we know how to double things, right? So she starts with $50, so we'll throw $50 in there at month 0, and every month she's going to double it. So the first month it'll be 100, then it'll be 200, then it'll be 400, then it'll be 800, right? And again, all we did was doubled, and to double means times 2, right? So times 2, times 2, times 2, times 2. Every time she just multiplied the amount by 2. So if we want to go ahead and graph this, we can say at 0 we're at 50, 1 is 100, 2 is 200, 3 is 400, 4 is 800. Look how fast that is going up. I'm going to try to draw this graph piece by piece here. I don't want it to be ugly. Okay. Could have been worse, right? I kind of messed it up there, but it's fine. So here we have a graph that's obviously not a straight line, right? Our last one was a perfectly straight line, changing by the same amount each time. And then the next graph, it increased a lot faster, okay? Now, something to think about is, which piggy bank would you rather have, and why? Well, if we look at this piggy bank, at month 4, she was at 800, and here, at month 4, she was also at 800. However, we can also notice that the starting values and like the intermediate values were different, right? At 0, it was 50, at 1, it was 100, at 2, it was 200. Whereas here, it was straight at 200, but then 350, 500, 650. The change is smaller, right? At month 3, the linear route, she had 650, but here, we had 400. So there's a difference. However, what if we went ahead and looked at month 5? If we had month 5 in here, we would have $1,600, whereas in the original piggy bank, if we added a month 5, we would have 950. Okay, so if you were to continue these tables, you would realize that this one, the change is much faster. Doubling your amount will have a greater impact than simply adding 150 every time, right? Because each time, the amount you double is going to be bigger and bigger and bigger. So we would rather have the second piggy bank. Right, because this is actually something called an exponential function. And the reason we would want this one is because doubling is better than adding 150. That's all for today.